In this part of the video, I will be explaining you how to practically implement linear regression code. For that, we will import certain models from Scikit-learn library. The first one is we will use the data set which is California housing prices, which will make predictions related to houses. The second thing that we will import is the linear model, which is our linear regression model. The third one is the train test model used to split data, some for training and some for testing purposes to ensure its accuracy. Then for visualization purposes, we will import matplotlib.pyplot as PLT. So housing is the variable in which we will store the fetch California housing, and we will create two variables, x, which is our feature variable. Housing.data includes all the data of the features, while y is housing.target, which holds the target column or something that we want to predict. To give you a little idea about how or what a California housing data set looks like, I will use DESCR to understand its description. So with that being printed in terminal, I will expand it so that we can see it clearly. So there is a description of the data set. It contains 2 lakh something training examples, 8 columns like bed, average rooms, average bedrooms, population, etc., which are our feature variables, and y is the price or the target variable. Now I will comment that out since it takes a lot longer time to load, and I will print what x and y features look like. So they simply look like numbers, doesn't give you any idea, but just to make you understand and show what it looks like, I have printed it out. As you can see, it contains only numbers and is not that important or significant. We will move ahead with creating our model. Or first we will split the data set into x train, x test, y train, y test using train test split, which divides the data set. Here the test size (0.2) means if there are 100 rows, 20 rows should be kept for testing purposes and 80 rows for training purposes. And x and y are the features that feature and the target variables. Now we have created a model which is the linear regression model, in which we will fit all the training x and y rows so that the model can create a formula, identify what the intercept value should be, what the coefficient of for each column look like. So here I'm printing the intercept, which is the starting value. So in the last video we have seen that linear regression formula is y is equal to mx plus c. So intercept is c, or the starting value. So model.intercept underscore, if you write, we will get the intercept or the starting value, and for coefficient we will use model.coefficient. Printing it out again. Here we will see the first value being our intercept, that is minus 36.90, and these are the various coefficients of each of the column. Now to understand which coefficient stands for which of the variable, we will be printing it in a format using this code. So feature comma coefficient in zip. So zip adds the input features and the coefficients together. So housing dot feature underscore name will be the name of the columns or the features, and model dot coefficient will be the coefficients. Running the code, we can see exactly for which variable what coefficient is being calculated by this expression. So here we can see house age coefficient is 0.009, average rooms is minus 0.103. Likewise, for every column or every feature, there is a coefficient assigned, which gives you an idea of it completes the whole picture. Now for prediction, we will use model.predict the value in x test. So x test rows are never been looked by the model. So these are like the test the model has to give, and the value it shows or the prediction it makes, if it is accurate to the y test, then the model is good. So the predicted value for x test is something like this. We don't necessarily need to know what it is, but if the difference between the predicted values and the actual value is large, then the model is not good. But if the difference is small, then it is considered to be a very good model. These are the predicted prices. Now we will also visualize it and see the plot. Like in the theoretical video last week, I have shown you the plot. Now we will actually write the code for it. So we will use scatter plot because it creates a relationship between the two variables. Now the two variables are y test and prediction. So y test are the actual y values and predictions are the y values that are being calculated by the model. So on the x-axis we will label it as actual and y-axis as prediction, and the title will be linear regression plot. Using PLT to show the plot. It takes a little time to load, but we will see how it looks like. So that's how the plot looks. So since there are approximately 2 lakh of points, we don't see it quite clearly, but like this is what a linear regression plot looks like. Hope you understand the code. Subscribe to my channel for more such videos.